Hi there, this is a quick review of factoring by decomposition. So anytime we have a trinomial like x squared plus x plus 7, but in a case where it's not just one x squared, we have another number in front of the x squared. There's a little bit more work to do than factoring trinomials without a lead coefficient, and we're just going to jump right in. So in this case, I'd like to start with just a review from FOIL so we can see where the steps are coming from. So for example, if I have something like 2x plus 1 times x minus 3. So if I had a question like this and the instruction was expand and simplify or expand fully using FOIL, I remember 2x times x gives me 2x squared. 2x times negative 3 gives me negative 6x. 1 times x gives me plus 1x. And 1 times negative 3 gives me negative 3. So when I simplify my like terms in the middle, I get 2x squared minus 6x plus 1x is minus 5x. Minus 3. So the question now becomes, what if we are given our answer as our starting point? So the question is 2x squared minus 5x minus 3, and the instruction is factor using decomposition. So first of all, I recognize I have to use the decomposition method because of this number 2 in front of the x squared. Now, before I jump in, I always want to check, can I common factor out the 2? So if all of the numbers were even, I would common factor out the 2 and leave that in front, and then I'd be left just doing regular trinomial factoring. But in this case, I can't common factor out the 2, so I have to do decomposition. So I start by making my sum product chart. And remember, what I'm really essentially doing is I'm trying to figure out how would I work backwards and know that those were the brackets I started with. So in my sum, it's negative 5, the coefficient of the x term, and my product is this number 2 times the constant term. So 2 times negative 3 is negative 6. And I'm left asking myself, what two numbers add to negative 5 and multiply to negative 6? And the answer is negative 6 and positive 1. So now that I know that, I've got to split up the middle term. And that's where the word decomposition comes in, because we're decomposing the middle term. And so we have to do this as an in-between step. And it doesn't really matter which order these go in, but I always like to look at, is there a number that factors better with the 2? And I'm going to put that 6 first. So I say 2x squared minus 6x plus 1x minus 3. And I can see if I were to collect my like terms again, minus 6x plus 1x brings us back to 5x. So I haven't changed anything yet. I've just set it up in a form where I can get it to brackets. So now what I look to do is I look to common factor the first two terms and common factor the second two terms. So I look at the first two and I say, what's the greatest common factor? And I say, okay, the number 2. And both of these terms have at least one x, so there's an x there as well. And now 2x squared divided by 2x is just x. And negative 6x divided by 2x is negative 3. And then I look at the second pair of terms, and I say there is no common factor. So I'm just going to write a plus 1 and x minus 3. So at this point, I smile to myself. And the reason I'm smiling is whenever I've got the exact same thing in both brackets, I know I'm on the right track. So the final step is just to pull that bracket out in front. That's my common factor. And what I'm left with is the other junk. And I just throw that in my second bracket. So it's x minus 3 times 2x plus 1, which is the same thing I had over here. It's just in backwards form, but it doesn't matter. So let's look at a couple more examples. The next example I want to do is 12x squared minus 5x minus 2. And if you're feeling like you might have this, just pause the video and give it a try, and then unpause it and see what I do from here. So I make my SP chart. My sum is -5. My product is 12 times -2, which is -24. And I say, what two numbers add to -5, but multiply to -24? And the numbers are -8 and +3. But what if I get stuck there? Remember, if I get stuck, I don't let myself be stuck for too long. I just take a moment and write out my factors of 24. And I say I can get to 24 by going 1 times 24, 2 times 12, 3 times 8, 4 times 6. And those are my options. And then I say, hey, if one's negative and one's positive, which one could add to -5? And I say, oh, -8 and +3 will work. So if I get stuck, I write out those factors. So now that I've got it written out, I say, okay, does either one of these go better first? And it really doesn't matter, but I like the 3 with the 12 because then the 8 and the 2 go nicely together. So I'm going to do it that way. So I'm going to say this is 12x squared. And I like the 3 with the 12, so that's plus 3x and minus 8x minus 2. And I can see all I've done so far is I've decomposed the -5x into positive 3x minus 8x. So now I look to common factor the first pair, and my common factor is 3x. And I'm left with 12 divided by 3 is 4. I had 2 x's, I took 1 out, I got 1 x left. 3 divided by 3 is 1. So a common mistake is, hey, 3x, I pulled out a 3x, I've got nothing left. And people will just write 4x and close the bracket. But if you expand back, you won't get this 3x term. So there has to be a 1 in this bracket to represent that there was a 3x there originally. So that's a common mistake. Anyway, moving on. I look at my next pair of terms and I say, what's the greatest common factor here? And the answer is -2. And -8 divided by -2 is 4x. And -2 divided by -2 is +1. And now I smile because I've got the same thing in both brackets. And that bracket becomes my new common factor. So it's 4x plus 1. And then 3x minus 2, the leftover jump, goes in the second bracket. So that's that one. I'm going to do one more example where we have to do some common factoring first. So in this case, I'm going to get a really ugly one, and it's going to say factor fully is going to be the instruction. And the question I'm given here is 6x cubed y plus 20x squared y and plus 14xy. And my rule of thumb is if I can common factor, I always check to do that first. And I say, okay, yeah, there are common factors between the numbers, but there's also x terms in all of them and y terms in all of them. So my greatest common factor for the numbers is 2. And I've got at least one x and one y in each term. So I'll pull out an x and a y. And what goes in the brackets, I say 6 divided by 2 is 3. I had 3 x's, took 1 out. I've got 2 left. I had 1 y and I took it out. I don't have any left. Next one, 20 divided by 2 is 10. I had 2 x's. I took 1 out, so I've got 1 x left. I had 1 y. I took 1 out. No y's left. And finally, 14 divided by 2 is 7. I had an x. I took it out. I had a y. I took it out. That's all I've got. So now I've got in my brackets something I can factor by decomposition. So I've got the first step I common factored, but I can keep going because I can still factor that trinomial. So over here, I do my SP chart. and my sum is 10, and my product is 21. And I say, what two numbers add to 10 but multiply to 21? And I get 7 and 3. So the next line, I just leave that 2xy alone out in front. And then in brackets, I've got my 3x squared. And I say, do either of these numbers factor better with the 3? And it's, yeah, the 3x. So I'm going to go 3x, and then plus 7x, and then plus 7. And again, I like to visually highlight that that 10x got split up into the 3x and 7x. That's where the name decomposition comes from, and that's what this method is all about. And then my next step is to look at these pairs of terms and do more common factoring. So I got 2xy, and now I'm going to have to do brackets inside of brackets. So I'll do square brackets, and I look at those first two and I say, what's my greatest common factor? And it's 3x, and in brackets, I'm left with x plus 1. And then I look at my next pair and I say, what's my GCF? And it's 7. And in brackets, it's x plus 1. And now, once again, I'm smiling because I know I've got the same thing in the brackets, which is telling me I'm on the right track. So the next stage is still got the 2xy. My common factor is the x plus 1 bracket. And my last bracket is the 3x plus 7. So I hope this has been useful to you. If so, like and subscribe, and check out microbruins.com for more math videos.